Hi, this is Alex and we are here in lesson 7. Finally, we have the whole core complete. Well, not the whole, but almost. We have all the core elements that we need to start playing around with the flow and all the new things that we've learned. We now have the timers, we have the instructions, we have the scene controller, we have the bootstrap area, and we have the flow, which is, for me, the core. The rest of things like the audio or the UI or the translation, for example, are just optional systems. I mean, of course, we are about to implement them in this course, but right now we have all the basics to start playing around. Now, the entry point of this whole architecture is our core singleton. And within the core, we have defined, let's zoom a bit, this flow database system, which is the entry point of how things are loaded in our game. This is our entry point, which is this flow database controller, the loader, and we have to establish which kind of flow do we want to load and what is the initial point. And then we have a list of flows that we can add, because we can have multiple flows. Like, for example, imagine a flow for the tutorial, a flow for, I don't know, someone who's paid and is in premium subscription, something like that, and you can have a different code. So, well, the point is that you need to define that JSON file, at least that one, and decide which one are your entry points. Let's take a look at that file. You see the boot game flow, which is exactly this boot game flow that we have over here, the base flow name, which is the name, the ID of this file. I mean, the file could be called whatever, obviously. We only care about the ID because this ID contains this flow with whatever elements we have defined in here. The important thing is we need that ID. So that's the boot game flow. And now within this level flow, we have different elements and we want one to begin with. So I'm going to start with the start framework. Call it whatever. Once again, this is just an ID. The point is that you have to establish what is the ID. You want to start in this one, you want to start in this one, you want to start in this one. That's up to you. In my case, I have defined this first flow action as my starting point. I'm going to delete these trigger conditions because they don't apply to this particular file. I mean, this is default JSON things that I add, but they don't apply to this particular thing. The point is we have the start framework, and this is the instruction that will kick off our game, the load core scene instruction. It contains some parameters, as we saw in the bootstrap lesson. What's our scene name, what's the bootstrap file attached to, and the flow action as we finish this thing. So the point is that we execute this instruction over here, and when it finishes, it will move to this flow boot scene. And this is our second step in the state machine. So pretty easy, right? So you have to define these files with whatever things that you want. And just to prove you the usefulness of this kind of system, let's imagine that I have this, like I said, to play adventure mode tutorial. That's the ID, and I will have some sort of actions gameplay tutorial. Obviously, that means that I need to define that file, tutorial, and the gameplay scene will be the same, and the scene probably I want as well a different scene to handle anything on the tutorial. That being said, within the menu, when we click on play, we can decide if we are about to play the game, let's say normal adventure, a new game, or we can play the tutorial if it's the first time that the user is playing the game or something like that. So thanks to this state machine on this kind of flow, we can define as many classes as we need, and each class or each thing, nonetheless, will do its own magic behind the scenes. I mean, the tutorial scene will probably contain some exclusive code for the tutorial. The actions gameplay tutorial will load some actions exclusive from the tutorial because we want to load some sort of special item for the tutorial or translations or things like that. So the point is that, as you see, it's really easy to add things to this core architecture. Well, let's get back to this load core scene instruction, because this is our entry point. And now within the core, we come to the start, we init the external libraries as we saw in previous videos, our .twin or any other thing that we might have. We have loaded our core system, which is the flow database, the game flow, the timers, the scene, blah, 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 blah. Nothing new and extraordinary. The important thing, the changes within the start. Now we have a delay if we want some sort of loading screen or something like that, or just to give the system enough time to boot everything. We can define that time. We have this delay time to start. And obviously using our timers, we will delay the execution, or we will call this initial load on start. And this will get the flow data that we have mentioned before, this start framework, and we'll call our flow controller with that list, whatever that list is, the list of all these flows, and we'll start the flow. That's the kickoff of the whole architecture. This is our entry point. There's nothing else for us to touch or to modify within this core thing. Now everything relies on the instructions. So let's take a look at the instructions. Let's go to the instructions, core flow, load core scene instruction, load core scene instruction. There we go, boom. This instruction, as we saw in lesson number 4, we have the pointer toward the scene, and then within the constructor we are about to read all the values that we have defined within our JSON file, which is this one over here. Like I said, the scene name, the bootstrap, the flow action, blah, 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 blah. And with all those things, we load the scene. And after the scene has been finished doing whatever thing it has to do, it will call this do execute on completion. And the execution moves from this scene to whatever the scene that we are loading. So we are loading, according to this file, our core init scene. So we just need to go to the scenes folder and find this core init scene. And within the core init scene, we are not loading any Unity scene because we're already in that scene. I mean, I like to start my game in this kind of core loading, bootstrap, call it whatever scene. So this is my starting point. I don't need to load any other scene because this is the scene that will kick off everything. It contains our singleton core and other singletons later on, like the database, the audio, things like that. But the point is that I'm already in that scene. So I only need to configure the next flow and the bootstrap area. When I do the on enter, I'm already here. So I obviously call the thing and I kick off my bootstrap area. I load the JSON file with the actions, this actions boot JSON. And in this particular instance, or for this particular lesson, I have created just a few. Our first one will be this action load stuff, and we have action do more load stuff. So the actions here will be all the things that you want to do in this particular scene. For example, when I boot a regular game, I will be probably, let's take a look, even though, monic domains, actions boot. I'm gonna put it in this one so we can see it better. This is a real example of one of my games. The first thing that I do is to load the languages, the translations, then I init the game paths, then I init my audio pool, then I init my FX controller, which is the particle system, then I init my screens controller, which is the UI, then I init the achievement score in order to listen to the achievements throughout the game. Then I have this gamepad disconnection module, and then I load in this particular game the atlas of all the sprites that I contain. So this is a real example of the things that you can or you can do in any of your games. Any of these actions, of course, contains dependencies, if any, and if you are waiting for the completion. If the completion is false, the dependency will just be skipped. I mean, there's nothing to do if you are not waiting for the completion. Otherwise, you will be waiting for the previous task or action to be completed. So pretty much that's a real example. So let's go back to our lesson 7. Like I said, I'm gonna wait for the actions to be completed, and the actions are the things that I'm loading within my scene. So presumably at this point on enter, I will be loading my Unity scene if I have to. In this particular case, I'm not, so I'm going directly to load the boot actions. And after all the actions have been done, I obviously destroy the actions, and then I just call the core to change to the next flow, which the next flow is whatever flow I have defined, which is this one, flow boot scene. And the core automatically will load this piece of code over here, will load this flow boot scene, will load this scene instruction with whatever parameters we have, which is in this case load the menu scene. We have some kind of flow to go to and the actions as well to load within that menu. So like I said, our core will change to the flow, and that's it for us. There's nothing else we have to do in this thing. You see, everything is kind of nice and clean because this scene is only taking care of loading that thing. And whatever that core scene has been changed or has been loaded or finished, we will receive this callback, the do execute on completion, which will just finish the execution and return the callback, which will do what we want to do, which is moving to the next flow. I mean, the state machine will take care of that callback to say, okay, you have defined this kind of a next flow action, so I have to move in that because you have finished this instruction. Like I said, pretty easy to follow. Am I right? Now, obviously, I have moved to the menu, so let's take a look at the menu. We open the menu scene, and in the menu scene, I added more things for this kind of example. I have a scene to load. In this particular instance, I'm changing to a new scene, so I have a new scene to load. So I'm gonna parse all those details, the scene to load, our bootstrap area, and the flow, if any. I'm gonna on enter load the scene. Now I am loading the Unity scene that I got, and I have this progress callback in order to display some sort of progress bar or whatever thing if you want, otherwise just passing null and that's it. And obviously I have the actions for the menu as well, and whatever actions that you want to do in your menu, like load the menu music, load the menu UI, load the menu translations, load, I don't know, menu characters, whatever thing that you have within your menu is something that you are about to do in this actions list. Because there's no other instruction or thing. I mean, the flow is just load this scene instruction, which is one scene, whatever scene it is, with our name of the scene, the Unity scene, the flow, blah, blah, blah. And then within our menu scene, like I said, we have this loaded scene and the callback on scene loaded. Now the Unity scene has been loaded and it's the time to load our boot actions. As usual, we'll load that boot actions for the menu, whatever actions we have, and we execute them all, and when they are finished, we will receive the on actions done. And on actions done, we will do pretty much the same as pretty much the others. So we will fade out, for example, the screen. In this particular instance, as I'm loading the menu, I want to get rid of the loading screen, so I'm gonna do a fade out. In this particular case, I'm just calling the callback. But in the, let's say, the real world, we have already our UI done, so we will be using this kind of code. Within the core, we are handling the loading screen, so I'm gonna fade out the loading screen, and when that thing is completed, I will call my callback. On the callback, I can do a lot of things. Like I said, I left this kind of information here in order to guide you things that you can do. Basically, at this point, you have faded out your loading screen, so you're supposed, like in this particular instance, to load your menu screen and to open the thing. I'm pushing the screen into my screen's controller, so the screen will be displayed on the screen. Or you can do any other thing, that's completely up to you. In this particular instance, for the example, I'm just moving into another flow. I'm just moving into the gameplay. Within this flow boot scene, the next flow action is the flow menu scene to play adventure mode. And this is, once again, the same instruction because the instruction itself is the same. The only thing that it does is to load a scene, and that's it. There's nothing else. The load the scene instruction does exactly the same thing. You pause the information, and then you call the start with the load new scene and the execute and completion. Nothing else or extraordinary in this particular instance. And like I said, after loading the menu, I'm gonna move to the gameplay. And if we take a look at this, we will be going to the gameplay scene Unity, and this bootstrap with some actions for the gameplay as well. They are just the same as before. I mean, nothing special to check in this particular instance. And let's go to our gameplay scene. And the gameplay scene pretty much is the same as the menu scene because we have almost the same information. We have progress loaded, blah blah blah. I usually use this scene in order to store information, like for example my gameplay controller, because anyone can access the current scene through the core. So you can call core.self.current scene and will return what scene it is. So you cast the scene to the gameplay scene and boom, you have access to the gameplay controller without having to search for any kind of game object or thing, because you have already injected this thing using an action. I'm using an action to inject that kind of thing. In fact, let's open one more time my own project, actions gameplay. Yep. Action set gameplay controller, and this action, as you might expect, the only thing that it does is to look for such a game object and get the reference and pass that reference to the gameplay scene, nothing else. So that way I inject that kind of reference, and from this point on anyone can access the gameplay controller through our scene. The rest of the code is pretty much the same. I enter in the scene, I load the scene, I hold up the percentage because I want to show my loading screen. When the scene has been loaded, I load the boot actions, and then I load the actions, blah blah blah, nothing else. After the actions have been done, I will call this a start game if my loading scene has finished doing all the progress and things that it has to do. And within the start game, one more time, it's up to us to decide what to do. We want to show some sort of a screen, or in this particular instance, I'm starting the second state machine, the state machine that controls the game itself. And that's my start flow, which I will be calling this gameplay controller, get gameplay flow controller, and I will be starting the flow with whatever flow has been defined or loaded via an action. So I mean, the actions is the place where I load and prepare everything. So that way, those actions are just small classes with that particular instance. Action loaded stuff, what it does. Not much in this case because this is an example, but one more time, I'm gonna open my own game. And let's take a look at some actions so you can have a better sense of the action itself. Let's say this one over here, boom. Let me close these other ones because they're not. For example, action audio pool. The only thing that I do is to call my core to init the audio pool, because in this particular instance, the audio is, like I said on the beginning of the course, tied to our core system. But let's pretend some other thing. For example, this one, action init game paths. I'm gonna instantiate the rewired prefab, and then I'm just gonna wait a little bit so that way rewired does its magic from behind, and boom. After that, I'm gonna init the gamepad and call this action to be completed and move to the next one. Let's say init the screen controller. This is what I was talking about. I'm gonna look for the game object that contains the screen system. Then I'm gonna init my root controller, and then I'm gonna parse some other information, and then I'm gonna set the screen controller to my system. I'm gonna init the screen controller, and then I'm gonna wait as usual a bit in order to let the system to do its magic, and after that call the onComplete. That's it. So that's what the actions are for, small pieces of code to do that kind of loading of one specific thing. I mean, loading the screen controller, load the gamepad, load our main character, load, I don't know, the enemy pool, load the audio, whatever thing that you want to do will be an action within that scene. So pretty much that's how the whole system works. And like I said, after that in my gameplay scene, I will start the flow, which will be a secondary state machine, like this one, for example. And within my state machine, I have this gameplay one because I tend to use the name of the level. For example, if the game contains level or world, whatever thing, you will put something like world 1, for example. World 1 if you want to. The point is that this is just the same state machine as our main core state machine. This controls the execution on the top level, which is loading the game and up to the menu, from the menu to the gameplay, to the gameplay to the menu, and loop over and over and over. And then we have the secondary state machine, which controls the gameplay itself. So for example, I have the intro state, then I start the game itself, then I can restart the game, I have this building thing because this is an example for a tower defense game. I have these checks in order to check certain conditions within the gameplay. For example, I'm checking here if I can modify the waves. Everything is handled by instructions as usual. I have this game loop to do more checks, like all the waves have been completed, then call the finish all waves. Check if the game over because my character died or whatever other conditions that I want to check within this instruction. And then our finish because I have finished the level, or game over because we died. So everything is just another state in this state machine that controls the game itself. In this game over instruction, we will call again the core in order to go back to the menu scene. So we will be doing something like this, but calling the EG core as we did before, like this one in the menu scene. We will call something like this within the game over instruction in order to go back to whatever flow that you want, like for example, let me check core, and where is the menu? For example, this flow boot scene will be our menu. That will be the exact code that we will be adding in this place. Like I said, pretty easy and simple. So I would say that this is kind of all the basics of how the system works. Of course, you have to define all these files. I have all these files here for you in order to serve as a template. And within the resources, we have the JSON actions, which are the actions for each scene. Like I said, whatever thing you want to load. And within the game, we have some common actions. For example, if there are actions that will be repeated in different games, for example, I usually tend to add this common actions folder. And then all the instructions that you might need to handle your game. One more time, I'm gonna open my own game to show you how many instructions you can have, because you can have tons of it. I mean, all the instructions that you might need. I have this, for example, folder with checks. In this particular case, there's only one. Oh my goodness. Always open that file. Let's close this one. So within the gameplay, I have this exit from game instruction, finish level instruction, game over instruction. And like I said, the game over instruction will call this change flow to whatever option I have defined, init game instruction, whatever thing I need to do to init the game itself. In this particular instance, I'm calling the gameplay controller to do this pre-init game from instruction, then init game, then subscribe to pause, and then boom, we are actually playing, because we are about to move to the next instruction, if any, because that depends on what you have defined within the flow file. If let me check this start. If I have defined a flow to execute, I will go to another instruction. Otherwise, I'm in charge within that instruction to tell the system where to move. But if the instruction is kind of automatically, because after the start, I want to call automatically this end turn and start my game, that's what will happen. Like I said, that's it. And you can have, take a look at this one. 17 steps on my state machine. My intro, my start, check player turn, because this is a turn-based game, the AI turn, the end turn, player check actions on whatever tile it is, the conquer phase that I have, fight for the player, events that I have, if you win the battle, if you lose the battle, if you tie the battle, if you restart the game, if you finish the level, if there's a game over, or if you exit from the game to the main menu. Like I said, lots of things. And the instructions pretty much should be self-contained, as we explained in lesson 4. And you have to do anything you want to do within this instruction to fulfill their goals. I mean, all the shitty code and all the things that you might need in here will be within this instruction. Let me check if I have any kind of instruction more elaborated. This one, for example, for the restart, I'm going to have a pointer to my game HUD screen, the gameplay controller, because I will want to show or hide the game HUD screen because I'm about to restart the game, or I want to open the HUD screen to open another screen, whatever thing. So you prepare all your variables here, and within the constructor and the init code, you get the references that you want. Like I said, thanks to the core, we know which scene we are on. So let's check if the current scene is the gameplay scene. If it's so, we just get the reference to our gameplay controller in order to be working with that thing within this instruction. And that's it for the rest of the things. I mean, I have a lot of things commented because in this game, none of those systems are still working, but as you take a look, everything goes or through the core or through the gameplay controller or any other controller or thing that you want to help you to achieve the goal that you are looking for. In this particular case, for the restart, most of the things happen in the gameplay controller in order to restart the system, remove the controllers, save all the data, remove all the screens from the UI, blah, 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 blah. Like I said, a lot of things that you might and or want to do. And this is pretty much the idea of the whole architecture. Now we have the architecture ready to create any kind of game. But one important detail, as you are seeing right now, this architecture is not really easy to handle, in the sense of, if you're about to create some sort of game jam game, this is not the architecture for you, because this is an architecture more elaborated, more complex, and you need more time in order to set up everything. So you will be wasting your 48 hours just to set up everything, like preparing the instruction that you need, preparing the flow that you need, etc., etc. So, but if you are making, let's say, the real game, this is kind of the architecture that you need in order to have your code pretty well structured. So everything comes in these instructions and the actions. So everything happens in the instructions. There's nothing else over there floating around. I mean, our gameplay controller will be just doing kind of, let's say, basic stuff. Let me check. Single gameplay, controllers, gameplay controller. Our gameplay controller will be only handling reference to other systems. For my map, I have a reference to a transform, to a vector, to a node for my map, to an audio file to get the level of the music, to the game logic, to the flow system in order to play around with all the instructions that we have created, reference to the camera, but there's no logic in here. Within this gameplay controller, there's no logic at all. There are only functions to add entities to this kind of level or remove entities. Our update mono behaviors, this is all the code that I have for my game. Update all the time system, update the entities, and update these other entities. That's it. There's nothing else within this gameplay controller to look after. Everything happens within each system. Whatever gameplay controller or let's say, for example, the battle controller or whatever other controller that you have will be taking care of these things through this update thing. And the same for the entities. I have a bunch of entities, my players, my enemies, things, and everything just be using this update method, and whatever thing is doing this pal over here, it's none of my business. And this guy over here will be just calling the behavior if it's an AI, or calling the updates, the update method within the components controller that I have, because everything is just a component within my games, and will be doing whatever magic you want. So the point is that the gameplay controller becomes just a skeleton, because I have just the systems defined. I add those systems to the list, and then I call the update. That's it. Whatever thing happens or whatever bug, you have to go and look after in whatever controller it is. There's a bug with your enemy controller, go there and look what's going on over there. There's a bug, I don't know, shooting, look for the component of shooting and find out what's going on. And the instructions pretty much the same. They are just a mere framework, kind of front end in order to call other things in other classes, but you pack everything into that one instruction. So for example, this finish level instruction should be taking care of finishing the level. So finish the level for me means that the character reached the end of the level, and I want to, for example, another good example will be, let's suppose that we need to find a key in order to finish the level. As soon as we get the key, we're about to open the end of the level door or something like that. That will be handled by our finish level instruction. As soon as I got that key, this finish level instruction will be called. So we'll be doing whatever thing it has to do in order to open that door. So we will get some sort of reference to that supposed door or whatever system that controls the door, anything like that. And pretty much that's it. That's what this finish level instruction will do. So well, I think that we have covered pretty much all the basics of this system. And if I'm looking correctly at my notes and what I'm seeing on the screen, there's nothing else for me to explain in this lesson. We have all the basics, you have all the code as usual in GitHub, so feel free to ask any questions or things. And I hope that you have a better understanding now that we have all the systems in play, because this is all the thing that you need to create your game. The audio is irrelevant, the UI is irrelevant at this point, or the translations are irrelevant at this point. Those are not vital systems to build everything that you need in the game. So well, I'm gonna wrap it up this lesson over here, and I will see you in the next lesson. Until then, see ya!